Now let's move on to question number 6. So once again, pause the video and give it a go. So in question 6 here, you have to first solve for 2x squared minus 15x plus 18, which is pretty simple because you just factorize. So if you do factorization, you should end up with 2x squared. You have to multiply to get 36 and add up to get multiply to get 36, add to get minus 15. So it should be minus 12 and minus 3, yeah. So minus 12x minus 3x plus 18 is less than 0. So then you factorize 2x squared, 2x, sorry, on the outside, x minus 6, and then minus 3 over here. So x minus 6 here too, and then less than 0. So x minus 6, 2x minus 3. So x is equal to 6, and then x is equal to 3 over 2. So x has to be less than 6 but greater than 3 over 2 to satisfy this. 3 over 2. There we go. And now b. So the function f is defined by f of x is equal to square root of our function that we just solved, where x is element of every single real number and x has to be less than or equal to k. Find the greatest value of k for which f inverse exists. So the inverse function exists. So right now we found out like in our first part we found this out. So this will play a key part in finding out the answer to question B. So over here we know that x has to be less than or equal to k for f inverse to exist. So we know that due to our function that we found over here, k has to be equal to 3 over 2, because the greatest value that you can get for k right now is going to be 3 over 2, because it has to be greater than or equal to, less than or equal to. Yes, so for f inverse to exist, we require, for f inverse to exist, we require 2x squared minus 15x plus 18 has to be greater than or equal to 0. Because since it is now in a square root function over here, this, whatever 2x squared minus 15x plus 18 is, it has to be greater than or equal to 0. So for that to happen, f has to be 1 to 1. If you don't understand what 1 to 1 is, I will be linking a video where I reference and teach what a 1 to 1 function is, what is a function in general. So if you take any value above x, above 3 over 2, you will not get a 1 to 1 function. And if it is not a 1 to 1 function, it is not a function at all. It is not a function, it's a relation. And that means that f inverse will not exist, as f inverse of a function only exists for functions. I know I'm repeating functions again and again, but you have to understand here that if k is equal to 3 over 2, if it is not equal to 3 over 2, and you take any value of x, if x is greater than or equal to 3 over 2, you will get a graph that looks something like this, like that. That means that the horizontal line test that we do, it will not work, as there are multiple intersections and this function is not 1 to 1. So for k to be, for this function to have an inverse, for it to be a function, k has to be 3 over 2. That means that x has to be less than or equal to 3 over 2. Then and only then will it look something like this, where there's only one singular intersection. Sorry, that's a bad example. Something like that, yeah. Okay, then only will it look something like that, where there's only one singular intersection for all the horizontal line tests that you draw. So I hope that makes sense now. So x cannot be greater than or equal to 3 over 2, and k is equal to 3 over 2. And I told you this is referencing back to our original question that we had done for part A. Now let's move on to question number 7. So consider the function f of x is